And welcome back, everybody, to Containers from the Couch. It is a Thursday, 12 p.m. Pacific, tiny bit later in my time here in Israel. Happy to have you all back. I have two wonderful guests today, Vibhav and Viji. I'm going to let them introduce themselves better than I can do it for sure. So, Vibhav, do you want to please tell everybody who you are, what you do here at AWS?
For sure. Thanks for having me on the show, Mesh. Surprisingly, it's my first time here in my 2.5 years with containers at AWS.
Welcome.
Thank you. So, hi everyone. Glad to meet you. I don't know if I've been with AWS for about 2.5 years now. My name is Vibhav. I'm a senior product manager with Amazon ECS. I've had the opportunity and the great pleasure to be able to influence a number of areas within ECS in this time across the control plane, data plane, deployments, storage, whatnot. And look forward to sharing some of the new things that we launched over the last few months, so that you're all caught up after holidays.
Nice. And Viji?
Hi everyone. My name is Viji Sarathy. I've been at AWS since September 2019, so about 3.5 years now. And all along, I've been in the role of a solutions architect. Currently, I'm a principal solutions architect specializing on AWS Container Services, which is ECS, EKS, and a whole suite of other ancillary services that are related to orchestrating containerized applications on either one of these platforms. So I work with a lot of AWS customers and providing expert guidance on either one of these services. And I'm happy to share the stage with Mahesh and Vibhav and talk about, and I'm going to show you a demo of one of the new features that we rolled out earlier.
Awesome. And my name is Mahesh Seidel-Casing. I'm a developer advocate with the Container Services team located out of Israel. And you probably heard me say this before, so I'm not going to go into what I do. But anyway, so let's dive in. We had reInvent approximately a month and a half ago, finished. And since then, in ECS, we've been very busy. And we've been delivering, of course, features on a regular basis. And that's what we're here to talk about today. So, Vibhav, would you like to kick us off and take us through all the wonderful stuff that we've released over the past month and a half, or even longer than that?
For sure. No, I feel it's something that we try to avoid as much as we can in across AWS, but it just somehow happens that a lot of our launches end up getting clustered for the last few months of the year. But one of the launches, in fact, that we'll briefly cover today is from even before reInvent. So, but without much further ado, let's move into it. Can I? Thanks for sharing that. So let's start by talking about this feature called Task Scale and Protection that we released, I think, at the end of October or early November in 2022. This is something. This addresses a use case that we've heard from a number of customers. GitHub really influenced this. I think there was a lot of chatter that we had in the community around this capability. At a high level, what this feature allows you to do is it allows you to protect tasks in a service from being scaled in, specific tasks in a service from being scaled in or terminated during a deployment. So what that means is, I'm making an assumption here that people are roughly familiar with what an ECS service is. In case you're not, at 10,000 feet level, an ECS service is basically a construct which allows you to run long-running applications deployed as containers using ECS. You can tell ECS, I want n containers, n replicas of my application running, and ECS will ensure that these replicas are running in a high availability fashion for as long as you want them, maintaining the desired count, and the application state that you configure in your task definition. So two key actions that happen over the course of the life cycle of a service are scaling and deployments. So scaling means adding new tasks or removing new tasks. So removing old tasks. So depending upon the amount of traffic your application is receiving, you might want to let's say in a steady state your service needs 3 tasks to serve all traffic. Now you see a spike and the service went up to 5 tasks, but later you want to bring it back to 3 as traffic recedes. So that's what we define as scaling. Deployment is quite simply the notion of updating your existing application. What that means is if you have a new version of the application and you want to roll that out, you tell ECS that, hey, ECS, this is my new container image. This is which contains the new application code. Why don't you replace all of the running tasks in my service and replace them with these new versions? Now, normally ECS will just go ahead. So in the scaling case, ECS will select 2 random tasks of the 5 that are running to kill, and bring down the desired count to the running count of tasks to 3. Similarly, in case of deployments, ECS will kill all 3 running tasks and replace those with 3 new tasks which have the new container image deployed. However, this can break certain type of applications. And Mesh, Viji, feel free to chime in with the types of applications here.
So I would think these are kind of applications that are longer running and they're still processing information. And for example, if you're downloading a file from S3, running a machine learning model on some kind of application it's a long running job. And you don't really want this to be stopped in the middle, because then if you do, then you have some other task has to restart the whole job again. And that's kind of a waste of time. And this is what this features helps us with.
Yes, I think that is one of the most important use cases I've heard, like generally large scale data processing. So think like you want to process graphics, things like machine learning, big data generally. Another use case I think I hear about is things like game servers. So if there's an active game, session on some of those 5 tasks, however, there aren't active game sessions on some of the other tasks, you would want the task with active game sessions to not be killed, because that would lead to bad customer experience. So
Exactly.
that's the other most important use case that I've heard around this feature. But what you can now do is that you can tell ECS that, hey, ECS, this task is doing some critical work. Don't terminate this. If there is a scale in, if you need to scale in the service, find a different task which is not protected and kill that instead. Or in case of a deployment, hey ECS, this task isn't ready for being updated yet. What this will cause in case of a deployment is for your deployment to be stuck for a longer time, because ECS will keep retrying to terminate this task until this task is ready to be terminated. But what it ensures is that no work that you need to, in case there is work that probably ran over, say, several hours, that won't be accidentally terminated because a code change got deployed due to some reason. And you can do this in 2 ways. You can do this from within the container. So we've exposed a new endpoint inside the container that you can use that a task can use to advertise itself as being protected from termination, as well as there's a new task protection API which you can use to tell ECS that a specific task is protected.
And this is run from the code inside the container itself. Within the task.
If you do that for using the endpoint, yes. For the API, like that really depends on you. You could do it from within the container. You could do it from outside. That's
okay.
Really dependent on how you do it.
Okay, cool.
All Right. I'm happy to answer any questions related to this now or
So
later.
at the moment, I think we don't have any questions from the chat from the audience. Please feel free to post your questions in chat. We would love to hear your feedback. And if you have any questions for both of our guests or for myself, please feel free to let us know. Yeah.
Awesome. Another key capability, and I think we launched this right before Christmas, is the ability
Christmas present.
Exactly. I mean, save dollars, like nothing better than that. And the capability to right size your compute using AWS Compute Optimizer, specifically for your tasks that are part of a service that is running on ECS Fargate. So Compute Optimizer is an AWS service which gives you right sizing recommendations for a number of entities, including Lambda functions, EC2 instances, EBS volumes. They recently added support for ECS services running on ECS Fargate. I think it's probably the easiest for me to just show it.
Okay, so let's have a look. Move over to your screen and we'll see what we can show you, how you can show us.
I have my screen open. Mesh, can we present that?
You are presenting.
Awesome.
Yeah,
So
you can see.
I'm here in the AWS Compute Optimizer console dashboard on my console. I haven't filtered for regions. You can filter this by region, but what this gives you is savings opportunity as well as performance improvement opportunities, segmented by the type of resource. So I have a number of ECS services running in my account, so that's why I mostly just see opportunities for services running on ECS Fargate. But let's double click into that and see what kind of information that shows us. So when I go into my ECS Fargate service recommendations, it gives me recommendations of two types: A, whether my application is under provisioned, and B, if my application is over provisioned. If my application is over provisioned, it gives me an estimated monthly saving amount, the opportunity size of the saving, obviously assuming the same if you made the change, and what the impact of that change be over the course of month. It says how much, what the right configuration should be. So clearly I've highly over provisioned these two services. I hadn't even realized that. So I've got a full vCPU core for one and half a vCPU for another, and instead Compute Optimizer is telling me use the smallest CPUs possible. Probably most likely because I don't have a ton of traffic coming in on these services.
Yeah.
But regardless of that, even if your service is receiving traffic, Compute Optimizer looks at the compute utilization across all of those spikes or whatnot that might happen in with your application, and makes informed recommendations which you can then use to optimize both your optimize for saving as well as optimize for performance. So fairly easy to use. I'll add a few caveats here around what this does require. So to get recommendations, Compute Optimizer does need 24 hours of running data for a given deployment before Compute Optimizer can generate recommendations. Mesh, do you want to say something?
No, I'm fine. I'll ask when you finished. You said the few caveats. The first one was the 24 hours. What else?
Then there are a couple of other caveats related to autoscaling. So service autoscaling, I think, is one of Viji and I's favorite topics. So in case you don't know, service autoscaling is you can autoscale a service in ECS based on a variety of metrics, based on CPU and memory metrics, but also on the basis of metrics like the incoming request count if your service is fronted by a load balancer or uses Service Connect, or think other relevant metrics. You can use custom metrics, any metrics that you feel are relevant. You can use that to auto scale your service. So if you use auto scaling for your service and you're auto scaling on one of CPU or memory, then then the recommendation will be for the other metric, not for the metric that you are already auto scaling on. And secondly,
Okay.
you can only use this for target tracking auto scaling policies. You won't get recommendations now for services which use step scaling policies.
And can you just give me the difference between the two of them? What's the difference between step scaling and target?
I think Viji might be a better person to speak to auto scaling policies.
Well, the target tracking is where you're specifying a particular target value for a certain metric, right? You might say that if you are scaling based on we call it as a utilization metric, right? You say that I initially have 2 tasks that are running, and I want let's say the HTTP request rate to be the target value of, let's say, 4 requests per second per task, right? And then, so what the service auto scaling will do in conjunction with application auto scaling, which is a separate AWS service that integrates with ECS, is that any time the target metric kind of goes above that value, it'll kind of proportionally increase or decrease the number of tasks, to make sure that the number of so that the target metric is always kept at that level. So suddenly, if the target were to spike up to 10, then from 2 tasks, you might launch at an additional 3 or 4 tasks, so that the average value comes below the target value. Whereas step scaling is just kind of what the name says, you kind of want to increase the number of tasks in some specified increments. Yeah.
And I see that this is also, as you say, scaling up. In other words, right sizing if you're under provisioned, and also if you're over provisioned as well. And I assume that this doesn't require me to do anything specific to my container. It's getting the metrics on its own from CloudWatch.
Yes, you don't need to make changes to your container. You just need to change
Awesome.
the task vCPU configuration and the memory configuration. Also, if you've set the container, the CPU and memory in container, you'll have to make the corresponding change, but not in your application code itself. Just in the ECS configuration that you have.
Awesome. Very nice. That's feature number 2 that we released, correct?
Yes, that's and awesome. I think this was the most recent. We released this right before Christmas.
And on the screen over here is a blog post which one of my colleagues, I think it was Nathan, which wrote partially this blog post as well about. So actually, the Compute Optimizer was a different one. The task protection was Nathan, my colleague. And this was done by somebody else, and I apologize, I do not remember the name. I'll quickly check it up and get back to you all. But yeah, there's a blog post also on this.
Venyan wrote that. He was the PM who worked on it from the Compute Optimizer side.
Thank you. Thank you.
Awesome. I think if there are no more questions, we can move on to the third one, and I'll let Viji talk about it and share the demo that he has for us.
Yeah. Do you want to? Okay. Yeah. I'll first explain it. So like the slide is showing. This is the ability to use Amazon CloudWatch alarms to monitor ECS rolling updates. As many of you that are ECS customers know, when you update an existing ECS deployment, it kind of does a rolling basis. It'll replace the existing tasks, with the new tasks, and sometimes. There may be some potential problems that, despite all the testing that you have done, when something hits production, you may have unanticipated problems. And we've had this capability called deployment circuit breaker, which kind of gives you the ability to automatically roll back the deployment if it repeatedly fails and doesn't reach a steady state. But then this one, that there were some limitations on how that circuit breaker worked. It was the threshold for failure was actually set based on the number of tasks that you launched and things like that. So this one, it gives additional capability of using a one or more CloudWatch metric alarms, so that you can actually, we talked about target tracking in the context of auto scaling. But then with a metric alarm, you can actually make CloudWatch, watch a certain metric to see if the metric breaches a certain threshold, either a upper or lower threshold. And when it breaches the threshold and the alarm goes from an okay to alarm state, then the ECS deployment service will automatically roll the deployment back to its original state. So basically giving customers additional capabilities to have control over how a failed deployment can be automatically restored to the previously good state. So that's what this feature is. If I left anything out, Vibhav, go ahead and add your context to it, and before I jump into the demo.
For sure. Thanks, Viji. I think the only thing I'd like to add, and thanks for bringing up deployment circuit breaker. I think that's one thing I love to say whenever I speak to customers. Please turn it on. For full transparency, I think it was not super resilient or robust when we released it 2 years ago, but today I think we have it in shape in a state that is useful for most customer use cases and provides a layer of defense against bad changes. But essentially what circuit breaker monitors is tasks that fail to start. So things like you've just written the wrong container image name, or there's a bad bug which leads to the container not even really being able to start or pass the health check. However, what we've heard from a number of customers is that even if the container starts or passes a basic ping health check that you might use, the the deployment might introduce a bug or a change which causes regression in metrics that you would otherwise expect to stay normal. Viji has a great example of that he'll cover in the demo. But basically, so I feel circuit breaker and CloudWatch alarms are complementary. Would say use circuit breaker as a default safeguard always. It's literally setting setting it to true in your ECS service. You don't need to really make any major changes for that. This is a slightly more advanced safeguard, but still a fairly pragmatic, easy and useful one, because it allows you to tell ECS that, hey ECS, this is the most important. Effectively, it allows you to tell ECS this is the most important metric for my application, and if there is a severe regression in this metric, clearly something wrong is being deployed. Roll back this change.
So I'm going to switch to your screen, Viji.
Yeah. So yeah, without further ado, I will start the demo, which should hopefully take no more than 15 minutes, and I'll say a little prayer to the demo gods. Anyway, okay. So are you able to see the PowerPoint
yes, we can.
screen? Okay. So this, the deployment setup that you see here illustrated in this diagram is what I'm going to use today for the demo. So this is a representative of a very simple microservices architecture where, in an ECS cluster, in a VPC, I have two microservices that I call front-end service and data store service that are running some number of tasks. The data store service is communicating with a Aurora Postgres database, and this service exposes a set of REST APIs that other services in that microservices architecture could potentially make use of to perform any sort of CRUD operations against that database. And one such service is that front-end service, which communicates with the data store service. And the front-end service, in turn, is registered with the target group for an application load balancer, and it exposes a set of APIs for users from outside the VPC to be able to talk to that service. So what we're going to do in the demonstration today is show, we're going to update the front-end service with a newer version of the container image, or rather a task definition, and show that how the deployment, which has been for demonstration purposes deliberately, it will fail, and we will show that how it can be rolled back based on a CloudWatch metric alarm. So the metric that we are going to be using in this case, and because the front-end service is actually registered with the application load balancer, the ALB, as you know, it publishes automatically certain metrics to CloudWatch without the customers having to do any kind of instrumentation in their application. And one such metric is the target response time. So we are going to use target response time as the metric for the alarm. And if the target response time, goes above a certain threshold, that is indicative of a potential problem with the deployment, and then the ECS deployment service at that point, we should see it rolling back the deployment back to its original state. So what I have, I initially I'm using this open source tool called Locust for generating a steady stream of requests. So the entire system is constantly under a steady load of about 20 requests per second. And as we are doing this update, just to kind of mimic what is going on in a production environment.
Okay.
Next, I will toggle over to my CloudWatch dashboard. And here I am, what you see here, this straight line in blue is basically the plot of the target response time metric, right? And as you can see that initially the target response time is averaging a steady value of about 50 milliseconds. And I will come to about what this dotted red line is, and that is the threshold that we have set. We are basically saying that if this metric is going to exceed this value of a threshold of 100 milliseconds and for some period of time, then that particular deployment is deemed to be a failure, and it will be rolled back. So any questions so far? Okay, so I'll continue by showing the lay of the land in my ECS cluster. So this is the view of the ECS console, where I have the front-end service and the back-end service that have been deployed. We are not using this CloudWatch agent for Prometheus in the deployment today, but I kept it there so that I can add some additional context after the demo when we actually want to do this kind of a deployment for some backend services. Now, when I go into this front-end service and then click on the configurations and tasks tab, and I will see at the bottom that it has got a couple of tasks that are running, and the task definition revision is 3. So what I will, for demonstration purposes, I actually have 2 in my task definition. I have 2 revisions, 3 and 4. And the one that is currently running is revision 3, and we are going to do a rolling update to revision 4. And basically, revision 3, when you look at the container image, it is using this image tag called normal, which is the one that is giving that 50 millisecond response for the load balancer. Whereas the revision 4 is the buggy version, which has the tag random. And when we deploy this, the code corresponding to this revision has been deliberately modified to randomly inject an additional latency of 200 milliseconds or so. So we should see the response spike up. Okay. So before I continue to explain things, and I'm going to go ahead and kick off this update, because it's going to take some 5-10 minutes for it to happen. I'll start it and then do some more talking. So first, when I do describe services on what is running in my cluster, you see that there is only one deployment that is running, which then that'll be called the primary deployment, and that is now in a status of completed. Okay, so and I'm going to go and update this deployment. And once I update this deployment, and moments later, when I do the same describe services, the command, you will see that there should be 2 deployments, right? One, the one that was previously running now becomes what is called active, and that is the revision 3, right? And then the one that we just rolled out, that is still in the in progress state, and that is the revision number 4, which now becomes the primary. Okay, so far so good. I hope that part is clear. So
in other words, we have a new version of the service which we're deploying, and this is now being marked as primary because this is the one where we want to move to, of course. But there's still one which is running in the back end, and we can see the containers and the task provisioning and activating in the background. But the active one, which is still running, which is version 3.
Right. So, when you go to the ECS console, and you can see that this is kind of a very dynamic environment because some existing tasks are getting deprovisioned, and then the new tasks are getting spun up and so forth. So now let me explain at this point what is actually happening behind the scenes, right? So when you do this type of a rolling deployment, there is a series of steps that takes place, with regards to the original deployment and then also the new deployment, right? The original deployment that was originally primary, as we saw, immediately changes the status to active, right? And subsequently, then, the tasks that pertain to this active deployment, they are deactivated. And then because this is also a service that is registered with a target group of the load balancer, they have to be deregistered from the target group of the load balancer, and ultimately they will be stopped, right? So that is taking place in one timeline. Concurrently, right, with the new deployment that you rolled out, and that is also getting provisioned, right? So, and that is now the primary. So the deployment service is provisioning the new task for that service, right? And then they will actually get registered with the target group of the load balancer, and ultimately they will actually reach a healthy state. Because when I go back to my target group of the load balancer, you can see here that two of my old tasks are draining and they're getting deregistered, while one of the new tasks has been registered and it is in a healthy state. So an important point during this deployment in this timeline is right here in this, but the point where the new deployment, the tasks, they reach a healthy state, right? So that point marks the start of what we call as the deployment bake time, right? So from that moment onwards, and this deployment bake time, I will elaborate a little bit more on it momentarily. So even though at this point that the new tasks have reached a healthy state, we're not going to say, all right, they are healthy, so the deployment is complete. We are going to keep the status of this deployment to be still in progress, right? And then kind of the deployment service waits for a certain period of time that we call it the deployment bake time, and waits to see if anything happens during this period. And anything happening is essentially indicated by whether a CloudWatch alarm is triggered or not, right? So as you see in this next slide, during this bake time, if something were to happen, if there is some canary in the coal mine, that actually indicates that something is going bad, and the CloudWatch alarm goes into the alarm state, then the deployment service will actually start rolling the service back. Okay, so and you can see that when I do the describe services again at this point, you can see that the new service, the primary, it is still in progress state. Okay, and then the old one has been rolled back. It is still active and it is completed, but then it has not been completely deleted because the deployment service kind of has to keep it in the back burner so that it can be reactivated if something were to go bad with the new rollout.
So, Viji, I have a question for you. You said the bake time. How do you determine the bake time?
Right. So the bake, yes. So that's what I'm going to explain to you next. So when I go into this CloudWatch metric alarm dashboard, right? When I created this, the most important thing that I wanted to show you is when I was actually updating this service, we have this deployment configuration, right? That deployment configuration, has all these parameters that, we talked about the circuit breaker, but most importantly, it has this alarms, where you can actually specify one or more CloudWatch metric alarms that the deployment, so that ECS has to monitor to determine whether the service is in a healthy state or not. And we are using one such metric alarm called, the high response latency metric alarm. And there, if you look at the alarm properties, it says that if the target response time is greater than 0.1 or 100 milliseconds, for 3 data points within a 5-minute period of time, those are the parameters that will say that this alarm goes into an alarm state, right? In other words, the bake time has to be determined sort of dynamically based on what are the parameters of the metric alarm, right? So in some cases, your metric alarm might have like a very short period. In some cases, if you think that your metric is not a very high resolution metric, right? If things don't surface up, very quickly, you might say, okay, I want this metric, if it exceeds a certain threshold, 5 times over a 20-minute period of time. So in other words, it is all the deployment bake time is sort of dynamically computed behind the scenes by ECS based on the parameters that you set for this metric alarm. Okay. So now, as you can see, you can see now that when I see that the alarm now went into this alarm state already. So you can see this, right? And the reason is because when I go into this metric dashboard, and because I rolled out this new version, and see that the target response time, it went above this threshold of 100 milliseconds. And you can see by these little blue circles that this is 1, 2, 3. It exceeded that 3 times, right? Which is what it says. And therefore, the alarm goes into that alarm state. And at this point, what the deployment service should have done, it should have flipped the 2 services. If I do a describe services again, and see what is actually the primary, right? The old one, the server with revision 3, which was made active, that has been reactivated and becoming primary, and it is kind of in the process of getting redeployed. And if I scroll down further and see what is active, and that is the new one that we deployed, or the new, or rather the old new one, or the new old one, or whatever you want to call it.
The defective version, let's call it that way.
The defective version. More importantly, if you look at the status here, the rollout state says it is failed, and also that the reason is because it failed because an alarm was detected, right? So this is a clear example of how this happened. And if you go back to your ECS console and then do a refresh on this, and you will see that you should see that the tasks that are having that revision of 4 should be in the process of getting stopped, and then revision 3 should be in the process of getting, which is what it shows. I think I think
what already happened, we were too late, and they've already been terminated.
Right, exactly. Yeah. So again in the target group also, you can see that this is the old task. If you which is getting drained out. So basically the whole thing, the new tasks have been registered back into the healthy state. And basically at this point that the deployment is, now you can already see that because the old tasks were restored, that the response time is going back down to the previous value of about 50 milliseconds. So that is kind of how the whole alarm-based rollback works in the context of a rolling deployment.
So I can tell you, for example, from my previous escapades to being some in operations and deploying production systems, which I once used to touch, which I don't do anymore. There was always these kind of problems of how do I know that my service is working correctly, and if I'm introducing a bug. And based on this feature that you're telling me, this allows developers and people who deploy service or operations teams, or whatever you would like to call the people which are managing infrastructure, more confidence in what they're doing. If they have the ability to understand, they say, I know that my metrics are supposed to be a certain value. If I do a new deployment and they drop or go above a certain threshold, I guess there's something wrong with the deployment, and this will automatically roll the things back to the previous version, which without them interact, there's no manual intervention here. It's all done by ECS itself.
Exactly. And I also I mentioned about, I will briefly talk about what is the point of back here, we had this the CloudWatch agent for Prometheus. So in this particular example, we were dealing with this front-end service that was registered with the load balancer, and we were conveniently getting a metric that was retrieved from the load balancer and published to Amazon CloudWatch. But let's say let us say, for the sake of argument, that you were doing the same rolling deployment for the data store service, right? And which is a backend service that is not actually registered with the load balancer, right? And still, again, you could always use like some standard metrics, system metrics such as CPU and memory that are readily available in ECS. But then those CPU and memory, they are not always the most reliable indicators of the canary in a coal mine, right? So now this is where you will have to rely on some custom application metrics that are retrieved from your service. So what you will then do is you will have to deploy an agent, either an open telemetry agent such as ADOT-Collector or CloudWatch agent for Prometheus. And if your backend service is instrumented with Prometheus SDK, it can actually gather those metrics, and this agent can then push the metrics to Amazon CloudWatch. And then at that point, a metric in a CloudWatch is a metric, no matter where it originates from. And then using that metric, you can create a CloudWatch metric alarm based on this custom metric, and then control the status or the fate of the rolling deployment based on whether that metric satisfies a certain threshold or not.
Okay. And all of this is explained in detail, I gather, on that blog post that I have, and I'll put it back up on screen, that you wrote, I think, correct?
That's right. I co-authored it with one of the service team members that worked on this nice feature.
Awesome. Perfect. So there's the link on screen if you want to read about exactly the full details above and beyond what we've gone over here on the show. You'll be able to see that there.
Yeah,
cool. So I guess the demo gods were with me, so that concludes my my demo. So.
Perfect.
I think that only two things, and like this is just like double clicking on what Viji said. This isn't necessary. This isn't restricted to services which use load balancers. You can use this for services which use Service Connect or services which pull work from a queue. There's no restriction on what metric you can create the alarm for. You can create the alarm on the basis of the metric that is the right representative metric for your application, and ECS will just monitor that. And secondly, the resolution of the metric is immaterial, or rather, it's not immaterial. It's obviously like it'll dictate how long it will take to roll back, but regardless of what the resolution is, the ECS is designed to monitor the deployment for a sufficient time based on the resolution that you have configured. So you don't have to worry about the metric not changing. In most cases, you don't have to worry about the metric not having enough time to react before the deployment finishes.
Yeah, well, the one thing that I very quickly want to add is, there's the dynamics are quite different between, when you're doing a rolling update of a backend service that is not registered with the load balancer, the dynamics, the timelines are a little bit compressed in the sense that, the front-end service, because it has to be deregistered from the target group of a load balancer, sometimes, that value is set by default to 300 seconds. And oftentimes, customers, they don't change that value. So you kind of get this automatic bake time of 300 seconds, for something bad to happen. But then in the case of a backend service, that is not registered with the load balancer, it happens very quickly because there is no deregistration delay or anything of that sort. So your actual rollout process itself might be done. The deployment service may be done with it within a minute or so. So it is realistically not possible. It is unrealistic to expect something bad to surface up within that very short window of 1 minute, and which is why we designed this deployment bake time, which is dynamically computed based on the parameters of the CloudWatch metric alarm that you specify as the criteria.
Perfect. And if anybody has any questions from the chat, please feel free to chime in, drop us over here over the chat. We'll be happy to answer out. This is a very cool feature. I can't actually wait to try it out on one of my pet projects. We'll see how it works.
We're super excited about it, and like just to share a little more of an internal view here. I think this is a very common. So ECS is used by a lot of other teams in AWS as well as Amazon, and This is something that all of those teams have requested us a lot for as well, because it gives an inbuilt safeguard for all of their deployments. So I think that should hold true for customers outside as well. And as a teaser, like we have a number of deployment enhancements that we are working on over the next few months. So we do expect to share more deployment goodness, because we feel more powerful, faster, more configurable deployments is one of the most important value adds that containers add.
And that, of course, most of the information of what we're actually working on currently is on our roadmap, which is available publicly on GitHub. You can see what we're working on, what we're interested, well, not interested, what we're busy with at the moment. And if you have any other requests or problems or features that you would like to see, please feel free to submit an issue to our roadmap. We monitor the issues on a regular basis, and we would love to get your feedback to hear what you would like to see.
And not to defend this, but even though you might not immediately see a response on everything, trust us, we do take we take
Definitely.
a frequent look. I know Mesh has something set up to give him a ping.
I have an alert for every single comment which comes in on the GitHub repo for the issues, that I get to my inbox to see and monitor every single comment which comes in.
I know Nick, who's the GM for ECS, has the same thing set up as well. So
Yeah.
we and I don't have that set up, but I do frequently monitor the repo. So even though we might not have the perfect cadence of replying immediately, but it sparks a lot of conversation internally.
So this was the third one. We have one more which we wanted to talk about. So let me bring back the slide deck, and I think it was this one, correct?
That's correct, Mesh. So somehow I think I forgot to add the sample code here, but this is, I'd say, a little more specific of a feature that we've heard and asked for. I think this also sprang from the GitHub roadmap. And just to be transparent, this had been on the roadmap for, I think, 4 or 5 years before we picked it up in this past year and delivered it. So basically, we've heard this ask come up from a number of customers who need a lot of ports to be opened on the container. So the most common type of use cases which might require such a thing are, say, real-time streaming applications or gaming applications, where you're hosting a lot of sessions on a single container, and you need to advertise an IP address with the IP address and a port to your to end users, so that clients can connect to that. So let's say you want to run 100 or 1,000 game sessions on a single task. And this is, I think, fairly common with things which use the WebRTC protocol. You can now tell ECS that, hey, ECS, I want 1,000 ports opened on this container. So ECS will open those 1,000 ports. You can provide the range of ports. So, like, let's say you want 2,000 to 2,100 or to 3,000, completely making up port ranges here. But you want to configure 1,000 ports to be opened. ECS will open all of those ports on the container and find corresponding ports on the host. So you can a little more of a deep dive into networking. So ECS supports 3 modes of networking. AWS VPC mode, which works with both Fargate and EC2, in which case your container gets an ENI or a network interface, so which includes a dedicated IP address, and basically almost think of it as a network card that's dedicated for your container. The second is the bridge mode, which is only supported on EC2, in which ECS selects a random port from the host and assigns it to the container port that you're looking for, and ECS does the mapping between the host port and the container port. And finally, the host network mode, in which case your host, you provide, let's say I want to use port 2000, and like ECS will open port 2000 on the host and open host 2000 on the container and bind it to the same port. Now,
Yeah.
what this you can use this capability with AWS VPC mode as well as with the bridge mode. So with AWS VPC mode, the the network interface is essentially isolated to your container already. So the ECS will open the same port on the host and bind it to the same port on the container. In case of bridge mode, ECS will open in case of AWS VPC, ECS will open the same port on the ENI and bind it to the same port on the container. But with bridge networking, ECS will randomly pick up a port from the ephemeral port range and associate that port with the port that you want opened on the container port. So if you want 1,000 ports, ECS will pick 1,000 ports from the ephemeral port range and bind them 1:1 to the container ports that you want opened. And
Nice.
there are really no limits. Like you can open 10,000 ports in a container if you want. I've heard from a customer who wants to do that. It really depends on the use case that you want.
And the configuration of this is within the task definition of the application itself?
Yep, it's in the task. Specifically, it's in the port mapping section.
Perfect.
And it can also be, it doesn't have to be some, it doesn't have to be some gaming application or WebRTC, and even some, traditional application. And I actually, it just so happened that right around the time that this feature was launched, just a week before, I was talking to a customer. They just had a traditional, one of your traditional, the applications that are running on ECS, but then they were using the port, the server port, they were using it as a mechanism for disambiguating the client traffic. I mean, that was just the mechanism that they had. Of course, there are very, very many other ways in which you can do it, but because of various reasons, that's the way that the client was choosing to do it this way. But so now a customer like that, they can easily just expose a multiple number of ports, and essentially expose the same functionality in your server application, which are exposed through multiple sets of ports. And like Vibhav explained, they can be bound to a different the port, the host port in the case of bridge networking, are exposed through different container ports with VPC networking, and this is a convenient way of doing it.
Cool. Our audience has been pretty quiet today. I don't know why. Yesterday was more busy, but that's okay. Days like this, days like that, it's fine. I would like to just point you all back, all the viewers as well, of course, again, to our roadmap, which is very important for us to share with you again, and I will do it one more time here, to please provide your feedback based on the functionality you would like to see. If you have any issues that you would like to raise based on things that you think are not working correctly, please raise those issues within our roadmap. We are monitoring this on a regular basis. And as I said, I get every single issue and comment from the emails into my inbox directly. So we do look at what's coming in. I'm very excited to see, as you said, we're going to have a number of improvements coming with deployments in the next year. So at the moment, we can't share exactly what those are, but they will be coming for sure. And they will be very, very useful for our customers as well. Before we close up today, I would just like to ask if there's anything else you would like to add, would like to share with us, where we can find you, how we can contact you if you would like to give your details. So, Viji, you start.
Or to get in touch with me?
Yeah.
Well, I'm old school, so I don't have a Twitter handle. So you can find me on LinkedIn as the Viji Sarathy, and at viji@sarathi.io. That is my email address. So either one of those is a good place to reach me.
Thank you very much. And Vibhav?
I will be honest, I don't use a ton of Twitter, but I do get notifications. So if you reach out to me on
Okay.
Twitter, I will respond. I'm also on LinkedIn, and my email is ag followed by my last name, my first name, Vibhav at amazon.com. If you want to talk about anything, I'm always happy to talk ECS.
Perfect. And my name is Mesh. My Twitter handle here is on the screen. DMs are open. I'm available whenever you want to ping me over there as well. I'll be happy to discuss anything also about the content we've spoken today, anything else which is containers as well. Thank you both, gentlemen, for your time spending to us today. It was very interesting to understand and see what the new features which we have. And we'll hopefully see you on a future episode of Containers from the Couch. And before we go, don't forget to hit subscribe on our YouTube channel. We would love to have you as a subscriber, so hit that subscribe button. And we will see you with an episode probably next week again. We'll let you know. Thank you very much.
Bye,
Thanks
everyone.
for having us, Mesh.
Thank you.
We'd love to be back soon.
Bye.